Question number 5. A student investigated how the mass of water in an electric kettle affected the time taken for the water to reach boiling point. The kettle switched off when the water reached the boiling point. Figure number 4 shows the electric kettle. We can see that this is a heating filament and the current is flowing. It means the high energetic electrons are moving inside the heating element. 5.1 is an A1 question. This question is from the internal energy and energy transfer in everyday appliance. The heating element of the electric kettle was connected to the main supply, which is shown here. Explain why the temperature of the heating element increases. We can see from here the high energetic electrons are moving inside the heating element. When these high energetic electrons, when they collide with the atoms of the heating element, they give the energy to the heating element and the heating element is getting hot. Let's see the model answer. The model answer is high energetic electrons enter into the heating element of the electric kettle from the main supply and collide with the particles mean the atoms of the heating element. It increases the internal energy of the particles of the heating element. Therefore, the particles of the heating element vibrate more rapidly. 5.2 is an AO3 question. Give one variable that the student should have controlled. In this experiment, the student need to control the temperature of the water. Therefore, the initial temperature of the water inside the electric kettle must be remain same in every single experiment or reading. Therefore, the initial temperature of the water or the kettle in every single experiment or every single investigation must be kept constant. If the initial temperature is different for every experiment, it will affect the investigation. Therefore, the initial temperature of the water or the electric kettle is always kept constant. The model answer is the initial temperature of the water or the kettle is always kept constant in every experiment. Figure number 5 is the relation between the mass of the water in grams and the time taken for the kettle to switch off in seconds, which is along y-axis. We can see that a graph line is present, which is not a straight line, it is a little bit curved line and it is unable to pass through the origin. 5.3 is an AO3 question. The student need to give the suggestion why the line on the figure number 5 does not go through the origin. The student need to give the answer that why this line is not passing through the origin. It starts somewhere from 11. The reason is the heating element takes some time to get hot. Even there is no water present there, we can see that no water is present there, and we turn on the electric kettle. The heating element of the electric kettle takes some time to get hot. Therefore, it takes couple of seconds to get hot, even there is no water. Let's see the model answer. The heating element will take the time to get hot as there is no water present in it. Therefore, it will take time to get hot even the mass of the water is 0 grams. 5.4 is again an AO3 question. Again, it is a suggestion based or reason based question. Suggest why the result give a non-linear pattern. If you look here, the graph, it is not a straight line. It is a curved line. Why the graph is not a straight line and it is a curved line? Student need to give the reason behind it. If you look the trend in the graph, as the mass is increasing, the graph is not going up. Instead of going up, it is going curved. So it shows that it is taking less time to get hot. So most of the energy is used to make the water hot or make the water to boil. So most of the energy is not wasted in the surrounding, which shows the efficiency of the kettle. Let's see the model answer. Use figure number 5. The graph is curved. Read the trend in the graph. As the mass of the water is increasing, the rate of energy transfer to the water is higher as compared to the surrounding. It means that energy transfer to the water is higher instead of energy is wasted in the surrounding. So the efficiency of the kettle increases with the increase in the mass of the water. Therefore, we can see as the mass is increasing, the less time is taken by the kettle to switch off, and most of the energy is given to the water instead of the surrounding. 5.5 is an AO2 question. The power of the kettle was 2.6 kilowatt. We need to convert kilowatts into the watt. The kettle took 120 seconds to heat 0.8 kilogram of water from 18 degree to 100 degrees Celsius. Calculate the specific heat capacity of water using this information. We know that energy is equal to mass times C times delta theta. E is the energy, M is the mass, C is specific heat capacity value, and delta theta is change in temperature. We know the mass is given here, that is 0.8 kilogram. We know that the temperature change is 100 minus 18 degrees Celsius, that it is 82 degree. We need to find the value of C, but if you look here in our question, the value of energy is not given. But on the other hand, we have it given the power, which is 2.6 kilowatt. So we need to use this value 2.6 kilowatt from our question to find the value of energy. And time is also given, that is 120 seconds. We don't have the energy value. First of all, we need to find the energy value with the help of power and time. And then we're going to use that value of energy in this formula to find the value of C. Let's see the model answer. Power is given 2.6 kilowatt. We need to convert kilowatts into watts. We know that 1 kilowatt is equal to 1000 watts. The 1000 is going to multiply by 2.6. We will get the answer, that is 2600 watts. The power is 2600 watt. Mass is given 0.8. Time is 120 seconds. And the temperature change we can find from here, 100 minus 18, that is 82 degrees Celsius. We need to find the specific heat capacity, that is capital C. We need to find specific heat capacity, that is C. First of all, we are going to use the formula that energy is equal to power into time, and we're going to use this energy into power into time here to find the value of C. So energy is equal to power, that is already given 2600. We're going to substitute here. We're going to use time, we're going to use here. So 2600 multiplied by 120, the answer is 312,000 joules. We will use this energy in this formula, and we are going to use the mass of water, that is 0.80 kilogram. We are going to use the temperature difference. We already found it here, and we will rearrange the equation to find the value of C. We will use this value here, and 0.8 and 82 go on the other side, whereas 0.8 and 82 will move to the other side of the equation, and we can get the value of C by rearranging the equation. After rearranging, our answer is 4756. After rearranging, the value of after rearranging the value of C is 4756. The demand of the question is up to two significant figures. 47, 4 and 7 are showing here two significant figures. The third number is 5. Therefore, we can increase this number by one number and it become 8. So it becomes 48 and rest of the two numbers will become 0. So C is 4800 joules per kilogram Kelvin. The value of C is 4800 joules per kilogram Celsius. The value of C is 4800 joules per kilogram degree Celsius.